Hi guys, welcome back to AI with MJ. I've been working on this Leetcode's interview crash course on data structures and algorithms. In the previous videos, I did the introduction and then started this chapter on arrays and strings. And and strings have a few common patterns. So I have completed two pointers, sliding window, and today I'm in this video, I'm going to be doing the prefix sum. So prefix sum is a not that common technique, but it is like a pretty good upfront technique that you could apply to an algorithm, which could save time later on. So it can be used on like arrays of numbers usually, and the idea is to create an array prefix where until suppose if we are on index 2, prefix at 2 would be the sum of all these elements in advance, like 0 1 and then 3. At 3 it should be 7. So when a subarray starts at 0, it is considered a prefix of the array, and a prefix sum represents the sum of all prefixes. Yeah, and we can want to sum the sum of the subarray from I to j. Then we do like prefix of j minus prefix of I minus 1 to get the window. And yeah, so here is an example. So if the sum of this subarray is 14, that is 9, 10, and 4, 14, and we want to find what is the prefix sum that give us the sum of these lines, then we can just subtract this part from this to get it as 14. So whatever the sum was up till here, we remove it from the sum up till here. And this is what it is. Like if you're at prefix j, then you remove prefix at I minus 1. Yeah, it's here's the pseudocode. You just basically add like the first element in the array and then go over the rest of the array until the end, and then just keep appending to the sum of the existing prefix in that window. Here's the example that if add the first number, then go all over all the numbers in that numbers list and then append it. And then you can check for I think the question was here to if a query is true, the sum of the subarray from x to y is less than the limit. So then you go over all the queries and then you check from the prefixes itself. Yeah, and this is like one of the ways to split the array. This is actually a medium problem, but like prefix sum, it gets really easy. And how you want to split the array is like if at any point that the first part should be greater, like the equal, like the sum of the first part should be greater than or equal to the sum of the second section. And we have to find like how many ways are there. So for example, if we do like 10 plus 4 plus minus 8 plus 7, whatever the total is, we'll have like in the prefixes set. Actually, let me just, no, well, they did not show it here, but if I open this, yeah, so let me just write it here. So in this one, there are two because let's say this is our num and this will be a prefix, okay? So which will be 10, 14, minus 8 is 6, and plus 7, 13. So right now, if we check that this part is not greater than the final one, so that is not a valid array. But when you come here, you see that this part is greater than this. So that is the first splitting. And then when you check like this part combined with 13 is greater. So that is the second split. Oh, sorry, my bad. This is one split because the sum here is greater than the rest of the split here. So yeah, this is what they do in the code, and this is pretty much it. Let's go to the next problem, which is running sum of 1D array. It's pretty easy. Description. I don't think it's asked a lot, but like it's a very basic problem, so you never know. It could be like the first problem they'll ask, and here you just have to we define the running sum as whatever index we are at. It will be the sum of all the numbers from 0 till that index. So here again, we'll just do like prefix, which will inside a list, we are storing it, and we'll add the first element in there. And then we go over from the first element to the end of the numbers, and we add prefix dot append. The current number that we are at, which is numZ I, plus the last number in the prefix, because that is what the total was. So prefix would be -1, and we will return prefix. Yep, it's not that hard. We're just like appending and adding. Okay. And then this is not a very common problem, so I don't want to do it right now. And here we'll just do this k radius subarray averages. Okay, so we're given a 0 indexed array, and we have to, and an integer k. The k radius average for a subarray of numbers centered at some index I with the radius k is the average of all elements in between the indices I minus k and I plus k. If there are less than k elements before or after the index, then the k radius average is -1. Build and return an array averages of length n, where averages is the k radius average for the subarray centered at index I. Okay, so what is going on is like we need to have 3 elements here before and 3 elements after, and then the average needs to be done. So yeah, this is not a very common problem either, but it sounded a little complicated. So for the first 3, the averages are just -1 because there are less than k elements before each index. But the sum of the subarray centered at index 3 with radius is 7 plus 4 plus 3 plus 9 plus all the 3 elements after. And then we have to make sure that like we start with k index from the starting position and then like k before. So our loop should only run in this 3. And then we have to find the output like in a list. So we can just define answer as a list. And we can just also like initialize everything with -1 because that's what we want, and then we can replace it in the answer times len of nums. And then we'll need like, we can just do n as len of nums here. And then we can go ahead and go over for I in range. As mentioned, we'll go from k to len of nums. Actually, I did define n, right? So n minus k. That is our window that we have to check. And we'll need prefix. So because if we have prefix, then it will be very easy to just check up the existing average and subtract it. So prefix here, and then we're doing prefix is equal to 0 into n plus 1. Plus 1 because we want the sum of first I elements. And then we do for I in range of n, prefix I plus 1 is equal to prefix of I plus nums at 1. And then we're going over total, which is prefix of I plus k plus 1 minus prefix of I minus k. And in the answer, we do equals total. And we have to divide it by 2 into k plus 1. And we return the answer. There we go. Interesting. Why is that happening? I'm not sure. I don't think this problem is even like that important. But I'm gonna end this video here. Thanks for watching.